So, about a year ago I was looking for something interesting to do as a coding side project. Back then, I stumbled across a video of DVGen on YouTube who got me interested in wave function collapse. It's a neat algorithm that can be used to generate procedurally tiled 2D and 3D worlds by defining what tiles can and can't exist next to each other. I wanted my project to have a clear goal besides just implementing the algorithm, and after a few days, a game I used to play when I was younger came back to mind. You may have heard of roguelike games or even played some of them. The core principles of this genre date back to the game aptly called Rogue, released back in 1980. The game I was playing adheres quite closely to the principles and gameplay of Rogue. It's called Pixel Dungeon and was released back in 2012. Since 2014, the game is open source, thus meaning I could freely use every asset to recreate the game using my own ideas, such as adding an extra dimension to the world. Combining the goal of building my own implementation of wave function collapse with the goal of recreating Pixel Dungeon's mechanics seemed pretty enticing. All it needed was a fitting name. Voxel Dungeon. Quick disclaimer. Just to be on the same page, this video will not cover the basics of wave function collapse and will dump down a lot of the concepts involved. If you're completely unfamiliar, I highly recommend this video by Martin Donald and this demo by Oskar Ståhlberg to better understand what makes this algorithm work. If you're interested in coding something similar yourself, this video by The Coding Train can serve as a great starting point. I will provide links to any content mentioned and some other interesting demos in the video's description. Starting out, I split initial progress into 3 steps. First, getting or creating the necessary assets. Second, building a simple version of the generation for only 2 dimensions. Third, iterating on the code until I can generate for 3 dimensions. All the original assets of Pixel Dungeons were easily available on GitHub. I wanted to keep the characters as 2D sprites whilst turning the wall tiles into 3D assets. Continuing with the voxel idea of the project's name, I used Magica Voxel to easily create stylized 3D models for all the initially needed tiles, 16 in total. All necessary sounds are also pulled straight out of the GitHub repository. Step 1 is done. My game engine of choice is Unreal 5. Initially, I also wanted to learn C++ along the way, but ended up exclusively using the Blueprint system. After about a week, I came up with a recursive solution to collapse possible solutions for 10 of the tiles and form simple rectangle-shaped rooms. It's a little slow, and I set all the rules for adjacent tiles manually, but great stuff otherwise. That's step 2 partially out of the way. Now I only needed to add the rest of the tile set, figure out stairs, and expand the algorithm. With progress being so fast, I also came up with another great idea. Why not make it infinite? How hard could it be? So I added that step to the list. Okay, listen. Things have gotten a little out of hand, but I think we can still fix this. Let me just first explain how we got here. It turns out that my implementation is really poorly optimized, and adding another dimension also adds a lot more iterations to the algorithm. Besides awful generation times, there seems to be a common issue of infinite recursions occurring. Writing out the rules manually was straightforward at the beginning, but became nauseating quickly, since every tile forces me to meticulously consider the interaction with every single other tile, and since I want to expand the tile set later, this simply will not do. While trying to generate larger worlds, it became quite apparent that generation also slows down with increasing world sizes. Since the algorithm sometimes has to update the rules of every single cell to run correctly, making infinite worlds like this won't work. After much additional work, and with these problems popping up, I pretty much hit a brick wall regarding progress on the project. This made me drift away from working on it for about a month. That was until someday I looked up if learning C++ would have saved me some trouble. But all I ended up learning is that if my implementation sucks, it doesn't matter what I code it in. Guess I'll optimize, I said to myself and went back to work. And boy, was there a lot of work. In order to keep the length of this video from exploding, I'll summarize the main runtime reduction I came up with in one word: lookups. Instead of constantly combining the collapsing rules during the recursion, I created lookup maps that allow for quick and efficient breakdowns of every step, and most importantly, a way to quickly find the cells with the least possible tiles in order to continue the recursion. I also limited how long the recursion can run before it allows the engine to update the image on screen, and this incidentally fixed the issues with falsely detected infinite loops. Next, I set myself an arbitrary goal of only using up to 0.01 seconds per tile in the editor, and after a few weeks of grinding down the runtime, the goal was met. Building a non-editor version also improved the performance tenfold. I was ecstatic back then when this finally worked. For improving the rule creation, I followed in Martin Donald's footsteps, since he came up with a great solution for this: a socket system. All I needed was to describe how each side of the tile looked and create a script that uses those descriptions to build me the entire rule set, even if I add new tiles afterwards. Getting this working wasn't particularly challenging, it just took a bunch of time. I'd rather have spent this time making something more tangible, but reminding myself how I'd be dying of old age setting up a billion rules made this much more palatable. After that was done and running, I thought about how stairs would be generated and settled on a combination of 3 tiles that force each other to generate should one spawn. After some tweaking, the resulting worlds were interconnected in all 3 dimensions. With all this work done, the third step was crossed off the list. Right here, the project finally started looking very promising again. This inspired me to create a character using this video by Cobra Code as a guide on how to do so the right way. Luckily, the created dungeons played well with Unreal's Navmesh system. So, one more step to go. How would I go infinite? How? How would I do it? Chunks. Just spawn in chunks one at a time. Closest first, ignore the ones that are too far from the character when it starts moving. I'm glad Notch already figured that out 14 years ago. Well, in truth, it wasn't that simple. For chunks to work, I need to code up a system that not only spawns the chunks, but also make it flexible enough to find the right size of chunk, detect when chunk borders are stepped over, combine and pass the information from one side of a generated chunk to the next, since the algorithm really needs it. This sums up how I implemented a procedural world generator using wave function collapse. There's still much to be improved regarding the performance, and I'd love to combine more straightforward procedural generation for things like pre-built structures and guaranteed paths throughout the dungeon. But this is where I am right now. I'm working on finalizing a publicly available demo for this project, and will post a link to it in the comments once it's finished. Thanks for watching.